Yo, what's going on, guys? Welcome back. Today we are doing Intro to Web Applications. We are continuing the path for the CJCA cert. We only have like 3 more boxes, so I know I keep saying this on every video. I'm going to try and knock them out really fast, but I really am trying to knock these out for you guys. Things just keep coming up, so I apologize for the delay in uploading, but this thing is not staying up for some reason. Let's see if we can fix that. But anyway, without further ado, we're going to go ahead and get into it. We're going to do, I don't know why that's not staying up, whatever. We're going to basically talk about web applications. I'll be honest with you, if you guys have ever worked with web applications in any capacity, this box probably isn't for you. This is kind of a dud box in my opinion. You'll see why. It's got good information, but all the questions and things are just Google questions, so I don't know why they even have you do questions. Just give the content and move on. But whatever. So they're talking about websites versus web apps. Back in the day, websites, websites are static. They don't change based on user behavior, and web apps do. So an example would be you log in, but you're XYZ person with XYZ roles, and when you log in, you can add customers to a database or something, and then when you search customers, guess what? That actually real time gives you new customers that you've just added, right? An old website didn't do that type of stuff. It would just, here's the content, right? This is what you get. Now you can actually change the content as you're doing stuff, right? As you're operating and manipulating the data. So one of the big things is it's modular. The display size nowadays, but pretty much every website has to be able to run in tablets and phones and all this. So it has to be able to dynamically change the display size, that type of stuff, running on any platform without being optimized. Web applications versus native operating system applications. So what's the big difference, right? If you go open up an application, like you can see, I have Discord running, right? If I open Discord, what's the big difference, right, between that and a web application? Well, a web application runs in my web browser. I don't need to download anything. I don't need to install anything on my system. It runs entirely in a web browser, and then the actual resource piece of it is being held on the back end or the server side, which is whoever's hosting the web app. That's who's dealing with all of that. So if you guys, by the way, check out the Discord in the Patreon below for all kinds of additional content. I just released how to do a tabletop for people trying to get into the industry, to get kind of your skill set up, and also to gain real world knowledge and experience, as well as make some money. I just released how to do that in the Discord, and we're going to be doing some live tabletops and stuff like that. So check that out, as well as all the other, I think I have a couple hundred videos or something like that in there. Let's go ahead and keep going. So web app distribution. So they're talking about here, these are many open source web applications that organizations use. WordPress is one of the most common, OpenCart, Joomla. There are also closed source, which is Wix. So like if you buy a website, you usually see it on Wix, Shopify. You hear a lot of these names. These are closed source, meaning that they're not going to give the code out open source, and people can just take it and run with it and do what they want. So security risks. So now we kind of get into what's the point of you knowing a web app, right? So web applications attacks are prevalent, blah, blah. So if you don't know OWASP, which we'll talk about, they literally have an entire, and you can see here's an entire testing guide on testing web apps. Great guide. But one of the things that they have a top 10 of attack vectors for web applications. And web application security risks, the biggest risk I see is speed. People want to spin up web applications because they think it's it's going to make them money, or they can like maybe you're a developer and you're developing something that's going to make the company money or whatever, and the company's excited about it. Well, they then push it out a little too fast, or they start pushing deadlines really fast. And the problem is any web app you use, and not any, but any customer facing web app, is getting exposed to the internet. So imagine you build a web app for you and your buddies, and you 5 or 10 people are using it, right? The chance of you finding a vulnerability in it is probably pretty small, because you're just using it, just 5 or 10 of you, right? You guys aren't, even if you had 5 or 10 of you review it for flaws, you're probably not going to find any. at least the small ones you find you'll fix, right? When you expose it to the internet, you now have millions of people being able to exploit that if they find it, right? There are tons of threat actors out there. There are tons of opportunistic threat actors out there. There's tons of script kiddies. There's tons of people specifically just searching for vulnerabilities all the time, right? And so because of that, you need to make sure it's more secure, which is why we see web application becoming more of an attack vector over the years, especially as we build more of them. WordPress, there's literally a WP scan, which is an entire scanning tool specifically just for WordPress. You see these all the time. Again, I'm not going to read this for you guys word for word because it's just kind of silly to read to you. But like you can see like things like this, like you can get full lists of people's usernames. To you, that might not seem like, you're probably like, it's whatever, right? But the reality is, even if I get a list of people that work there, that is a huge flaw, because now I can just take my attack and within 20 minutes, I can set up a password spray attack and probably get in. And then it's like, oh, that took 20 minutes, right? Maybe they have MFA. Okay, well, next step is bypass the MFA. Okay, no, what's the next step, right? And you can build out this attack with like almost no time. And so you're seeing it become more prevalent and more risky. So you can see here's some of the different flaws in the real world scenarios. They have SQL injection. They mentioned it, obtaining usernames, performing password spray, file inclusion, reading source code to find hidden page. So this is actually kind of normal. File inclusion, you can actually access files you shouldn't, and then, or I say shouldn't, but you shouldn't even know about. And then when you do that, you can actually start spidering the website and finding more and more and more. And sometimes when you find more and more, a lot of times there's exposed things that people the company doesn't even realize they're out there. IDOR, insecure direct object reference. When combined with a flaw such as broken access control, this can often be used to access another user's files. So IDOR, insecure direct object, you're referencing something that you shouldn't be able to reference and being able to pull it. So for instance, there's something on the website referencing whatever, right? Like who knows, right? But then you change it and you reference another file that you know is on the server and it actually shows it. Well, now that's a problem, because now I can actually display things on the server. And for instance, there's usually passwords, usernames, databases, those types of things on the back end. Broken access control, application that allows users to register a new account. If the account registration functionality is designed poorly, a user may perform privilege escalation when registering, considering the request when registering a new user. So this is what the request looks like, right? Username is B Jones, password is welcome, email, local, blah, blah. And then they have the role ID. Well, if you change that role ID to like 1, because usually the first person that registers something is the admin. Well, guess what? Now they just gave you admin, like things like that, broken access controls. So things that you shouldn't be able to do to gain privileges, to gain access, right? Okay, web application layout. So no two web applications are identical. Businesses create web applications for multiple uses and audiences. This is the key, is no web applications are identical, but they all have to rely somewhat on the same underlying technologies. And people don't fully understand that, because people think coders develop something totally new, and they do, but they still have to follow standards and procedures. And the reason they have to is because if I create a web app completely from scratch and it's totally foreign, you guys have never seen anything like it in your life, nobody can interact with it because it has to render in your browser. So if you're not following those standards, the browser's not going to know what to look at. It has to comply with certain things to be able to talk to a database, for instance. Like if you have a SQL database, there has to be a standard so that it can talk. Otherwise, you can't talk to that database, so you can't store usernames, et cetera, right? You have to have standards and processes. So the underlying technology has to be the same. And you'll see, we'll talk about full stacks and things like that here in a little bit. But so web application infrastructure, there's the actual infrastructure. This is the actual components, right? The databases, the web application can be set up on a separate server, blah, blah. So this is the actual physical, like what is it sitting on? Is it on actual server? Are all the components on one server? Is it spread out? Is there a load balancer? Those types of things, right? Web application components. The components make up a web application, represent the actual components. So this is basically, hey, you have your user interface and whatever the server components are for the web app itself. The big difference here is the infrastructure might have, like I said, 10 servers if it's a large website, right? Because you might have load balancer, redundancy, all that stuff. But the web application components are just going to be what is being held on for just the web app, not the database and all that stuff. The architecture comprises all relationships. So here we see this is the relationship, right? So we have our server, and then they're showing different types of clients. You have different computers, you have your iPhone or whatever, laptop, all connecting to the server. This is a client server model. One server, this is your client, all connecting to one server. This is, you notice the database is on the server as well, which that could be the case if it's a small one, but this is kind of what you're most likely, well, not with one database, but then you have your clients all connecting to multiple servers. This is again, so I haven't been a sysad in a long time, but back then, even when I was, a normal server could handle someone like actively using the web app or whatever. And this was a pretty heavy web app as far as resources go. It could handle like 30 to 40 people actively on that server. I don't know what it is now. I'm sure better technology and lighter weight web apps, you could probably handle more. But if you have a pretty extensive website that needs a lot of traffic or meets a lot of traffic, you're probably going to have a lot of servers load balancing, meaning, hey, whenever 100 people hit this, we're going to say, hey, that's okay. We're at our peak or however many we can handle. Let's start going over to this one and then start failing over to this one. And that's not actually how it does it. It actually load balances, like it'll send one here and send one here and send one here, and it keeps the load balanced across them. But the point is, it's so that the server doesn't crash just because you have so many people hitting it. An example I like to use for this is video games. You see all the time, like Battlefield or Call of Duty or anything like that, right? Battlefield we'll use as an example. Battlefield and Call of Duty and all of them, Warzone, you have like, I think at most maybe 150 people in a server, right? There's a reason they keep it at that, right? They could do things like MMOs do this sometimes where they'll have like 1,000 people at a time or whatever. The reality is what's probably happening is they're actually presenting that web app, which is the game, right, across multiple servers, and they're correlated together and they're linked, but you're actually touching different infrastructures. Now, that might not be the case with things like Call of Duty because it's low enough numbers that they could probably squeeze them in there if they up the server and etc. But it is probably the case it is the case for like MMOs that have a ton of people. An example would be like, I don't really play MMOs, but like if you go into an MMO and you go into a world and you notice there's a load screen and then you go into a town and then there's like 100 people in that town. You probably all are on the same server. And then as soon as you leave the town, it probably loads you somewhere else. So that way you're in the server with those people because you can't render everybody and all the resources in the entire world right there. So it's just kind of an example of how they get creative with ways that they can spread this load over servers. This is probably what you're most familiar with seeing, and that is clients, servers, databases. You might not even realize this happens, but most companies have multiple servers that are presenting the web app and multiple databases storing the data. The reason for this is 1, again, load balancing, 2, redundancy. If this database goes down, we're not screwed, right? Because if you look at this one, if this database goes down, if something crashes, nobody can authenticate, nobody can get in the server, etc. So this is probably what you're most likely used to seeing. You just don't even notice it. Okay, so web app components, you have your client. By the way, just my opinion, if you're going to show diagrams of infrastructure and how it operates, you probably ought to break down the components before you display them so that people don't go, well, I don't know what I'm looking at. So the client is just you, right? Whatever you're using, your phone, your iPad, your laptop, whatever. The server, that's these here. This is the actual web server, the web app logic. The database isn't necessarily, some people will store it on the same thing, but they're showing that a database can be its own server over here, right? So a server is just a piece of hardware that you're using to host the website, the web app, and then also host the database. Services, third-party integrations, web app integrations. So an example might be, hey, I go to buy something on this website and it asks me to go to PayPal, right? Well, it opens up that little tab, right? That's going to be a third-party integration. I don't have PayPal. I'm not hosting PayPal, right? I'm going to have PayPal pop up and it's just integrated directly in. Then functions, serverless, we'll talk about that. Web app architecture. So this is basically what you're looking at from, so you can see they have the presentation layer. This is your UI, user interface, everything that the person's seeing. Then you have your application layer, ensures all the client requests are correctly processed. So this is actually the function of the application, right? It's when it's doing something, when you're requesting something, when you're making, and when they say request, they're talking about like when you're manipulating, editing, anything like that, it's got to send a request. So anything you're doing here, it's going to actually do that on the application layer. And then the data layer is basically where's the data going to be stored? Can it be accessed? Everything like that. So on the actual database. Now, again, depending on your infrastructure and architecture, how it looks, this could all be hosted on one server, right? If you have a small website, it's probably on one server. Then there's one database. It's all probably hosted on the same thing. So here, this is kind of the client, IIS, and then you see here's the core web app, and then you see here's the database, and then you see here is the identity provider. So this is who is authenticating. So again, you might see it as like when you authenticate to a website, you might think that it's all stored in a database, and in some capacity it is. But like let's say it's linked to Active Directory, like in this case they show Azure Active Directory. It is a database, but it is actually going to reach out to Azure and say, is this person authenticated? Can they go ahead and get in? An example of this is when you guys say, when it says like, do you want to continue with Google? And you click yes, and you're already logged into Google, so it authenticates for you, and etc. That is the same thing. It's using that as the identity provider. Now, third-party services, this is all dependent on if you want to use your own. So example is SMS service. If you want it to shoot you a text message for something, right? They might use Twilio or something else, right? That's a third-party integration. So that's kind of what they're talking about. So microservices, think of microservices as independent components of the web app. These are, which in most cases are programmed for one task only. For example, an online store. So these are, if you've ever done programming, and you think of like, or even like DLL files, if you know what those are. But basically, these are small programs, if you will, that do a task that you need it to do that are part of the web app. So for instance, registration. When I go to register, there's we're just calling it a program, but there's a small piece, a microservice that runs when I register, and it does a task, right? This stops, and video games do this too, and everybody does this, but basically what it does, it saves resources, right? I don't have to load everything about the website if I'm only using this function, right? It will load the function that I need as I go, right? If I'm not going to pay for anything, why would I load the entire payment function and have it do everything when I'm not even paying for anything? So that's kind of why they use these microservices. The stored data is stored separately. Okay, so we just talked about this. Easy deployment, reusable code, agility. Reusable code is one thing I didn't talk about, but an example would be, hey, we're doing a registration. Well, the login is going to be fairly similar as far as reaching out to the database. The difference is going to be the command instead of reaching out to the database and adding a user. It's going to reach out to the database and query a user. So that's kind of some of the difference. Serverless cloud providers such as AWS, GCP, Azure, among others, offer serverless architecture. Yep. Basically, what this means is you're gonna containerize it. They're gonna run in a stateless mode. And what happens here is the company, Azure, AWS, GCP, all of them, they're hosting everything. You don't need a server. You're not standing anything up. You're not doing anything. You're using their hardware, and you're just hosting a container on their hardware. It's very similar to like, think of like VMware, but very lightweight compared to it, because VMware still hosts full operating systems. This isn't a full operating system. It's a container that uses just what you need in it. All right, security. So they're just talking about basic security here. Like, it's important when performing a pen test. Individual web app vulnerabilities may not necessarily caused by a programming error, but okay, whatever. So an example is role-based access. What they're saying here is users may be able to access admin features that are not intended by directly accessible to them, or even basically what they're saying here is if you mess up the architecture, there might not be a way to fix it without just completely redoing the architecture. That's what they're saying. Because, for instance, if you're using, like we talked about, if you're using an identity provider and the flaw is in, just give you an example, is, hey, Azure Active Directory, the problem is people have too much access, okay? But they need that access for something. Well, the only way to redesign that, if they're the architecture is working the way it should, the problem is in your identity provider you're giving them too much access by roles or groups, but you can't take it away because they need it for something. That's when you run into the problem of we have to redesign everything because that's not what we intended, but that's what's happening. Okay, so now we have our terms front end or back end. So front end, I don't know why I'm saying it that way, but front end, web application contains the user's components directly through the web browser. So this is what you're going to see, the actual code you're seeing here. Everything you interact with, everything. In modern web apps, front end components should adapt to any screen size. We talked about that. An example of the front end is like this. This is HTML code. It's very basic, but this will basically print out, this is some blue text, this is italic text, etc. Right? The back end is the actual servers. So an example here is, this is your back end. This is the Apache, which is actually running the web app. Then you have the web application itself that's sitting on the back end server, and then you have database that's sitting on a back end server. So the back end is the actual server itself that's hosting all of this. Something has to run or some hardware has to sit somewhere for someone to host this, right? It is possible for it to host its own isolated server, isolated containers such as Docker. So you could have one server where everything's isolated. It's possible. It would be fine for smaller things. It would even be fine for bigger things. You would just still have to have load balancing and stuff like that. So securing front end and back end. So this is just the most common. It's hard to go through this because it's such a silly thing to just mention a couple, in my opinion. Like, you're not really learning anything from this, in my opinion. So they're just saying, like, hey, for instance, if we have a search function in a web app that mistakenly doesn't check the queries correctly, or doesn't have input sanitization or input validation or anything like that, you can do SQL injection. Like, okay, cool, thank you. Like that, in my opinion, it's not, you're just showing examples, but this is important. The top 20 common mistakes web developers make that are essential. This is really important because this is what we're looking for. We're looking for mistakes. Technology itself is not flawed, right? We make it. So we make it flawed. So understand that. It does exactly what we tell it to do. So permitting invalid data to enter the database. So this is the number one mistake, right? An example would be SQL injection. If you don't sanitize my input, if you don't validate the input, I can put whatever I want into it. I can permit it, right? Focusing on the system as a whole, establishing a personally developed security methods. So not following best practice, basically. Treating security to be your last step. I see this a lot, actually, which is treating security as your last step. They will build their code to make it do everything, and then they'll go, all right, what do I need to do from a security perspective? And they ask the security people, and the security people are like, well, your whole thing is broken. Like, you can't do this. Plain text password storage, weak passwords. I'm not going to read all these to you, but you get it. Then the mistakes that lead to OWASP top 10, these are the OWASP top 10. This is the basically all web app top 10 vulnerabilities that they see. And they update this. When I say regularly, I think it's like every few years or something, but it is updated. So I would check it out because it is interesting to see that, like, some of them have been on here for a long time. Like, some of the same techniques have been on there forever. And it's like, don't people fix things? And sometimes they do, sometimes they don't. So here we have HTML. This is what HTML looks like. If you don't know HTML, you're not going to learn HTML just looking at this box. So just understand the basics of it. You have your HTML, your head, which is your title, basically. Your head actually is your heading, but, excuse me. and then they have the page title, then you have a body, which is again like the body of the page. And then you can see here's the structure of it. Again, I'm flying through this because this is silly to try and teach you HTML with like 2 paragraphs. If you want to learn HTML, go learn HTML. If you can read HTML, you can handle most web apps, because most web apps, the HTML is the least complex part of the whole thing. Okay, URL encoding. An important concept to learn in HTML is URL encoding or percent encoding. For a browser to display things, it has to know the character set. Basically, if you have a character that that the URL can't understand, or HTML can't understand, you can encode it with these. You can URL encode anything with CSRF and stuff like that. You need to know how to do it. You don't need to memorize these. I've never had someone be like, %21 is exclamation point. Like, you can literally just Google it. You can CSRF. You can do all that. Here you go. Here's an entire table for URL encoding. You can go to that if you want. The head element contains elements that are not directly printed on the page, like the page title. So what they're saying is, if you look, these elements are just telling it the page where to display it, not necessarily actually saying, hey, we want you to print the word head, right? Okay, so now here we go. Each of these elements is called a document object model, the World Wide Web. Okay, so now we're talking about CSS and JavaScript, which is what most websites are going to start being built this way. When I say that, I'm saying like we're past HTML. We have been for a while. So it's a platform and language neutral interface that allows program scripts to dynamically access and update content. Okay, so the DOM standard is separated into 3 parts: core DOM, standard model, standard DOM for XML, and standard model for HTML. Okay, awesome. Let's keep going. Oh, sorry, this one actually has a question. Was the HTML tag used to show an image? They didn't mention this. You have to go to Google, and you have to Google it. It's literally IMG, and there you go. Okay, so now we go to cascading style sheets. So this is where you're going to actually stylize and make your website look nice. So the reason you do this is you build an entire, I'm just going to summarize this for you guys, because again, this box is not going to teach you to build a web app. There are boxes designed for it. There are instructions out there. There's all kinds of resources for building websites and web apps if you guys want. This isn't it, I promise you. So basically, long story short, CSS, what it's going to do is it's a page that you can put in all of your information about, like, I want all of my titles to look like this. I want all of my pictures to look like this. I want all of my headings to look like this, all my bodies to look like this. And you put all of these, and you can even put them like, I want only the HR pages to look like this, and I want only the whatever. You can make this as complex or as simple as you want. And the reason they do this is if I want to update the website and I say, man, I want to change maybe our logo changed. I don't have to go to every single web page and change the logo manually. I can go to the CSS and I can go logo image the image tag, whatever, and change the image. And now that updates on every page of the site that you built it. So much, 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 much nicer. So you can see, here's an example. Here you go. So you can see like the body, they have body here, title here, paragraph here, blah, blah, all that stuff. Canyons, all this stuff. See how it looks nice and all that? Well, in HTML code, you can see here's our HTML code. They have our slots, blah, blah. And you can see here they have auto compress, format, fit, crop, width, height, all that stuff. They have to put all that, right? Here, all of that's put in here. And then every time they add one of these cards or whatever, they can just mention it. And you can see it actually puts it all there for you. All right. Okay. And they're saying here that CSS can be used for advanced animations for wide uses, all that stuff. Yeah. So CSS cascading style sheets changes the style, changes how it looks, makes it nice and pretty. You still have to put HTML code in, but CSS makes it look nice. Okay, frameworks. So what they're saying here is there's a lot of frameworks that are optimized for web applications. So again, I told you guys, you have to follow a standard. You have to. If you don't, your web app's not going to play nice with everybody. So using one of these frameworks will help you tremendously. Go through, check them out if you want. What is the CSS property value used to make an HTML's element text align to the left? Well, it's literally called text-align, left, semicolon. Pretty simple. All right. JavaScript. This is one of the most widely used languages. JavaScript is usually used on the front end of an application to be executed within the browser. So your browser executes this, not the back-end server. It's really important to understand those differentiations because that's kind of what you're going to run into when pen testing. Excuse me. So while HTML and CSS are mainly in charge of how a web page looks, JavaScript usually controls the functionality. So for instance, when I register, if I register for the website, I put in my username and password. The JavaScript might mention run this script on the back end, right? It's telling it to do something. And so the JavaScript code actually adds that functionality to the site. And there's all kinds of ways to do this. But for instance, what you can do, script source, script.js. So you can say, hey, when you do X, click this button, run this script. And it will run a JavaScript that's located somewhere else. And it can actually run that and then do whatever functionality you want. So an example they use here is document get element button 1, and they have it to change text. So that's what's right here in this. That's the code for this. When I click it, it's button 1. You click it, it changes the text. That's the functionality it did. So an example might be, hey, what theme do you want? Green, blue, orange, whatever. You click blue. Blue runs a script that changes the function or changes the view, the CSS for you to look pretty, right? Okay, so usage. Most common web applications heavily rely on JavaScript to drive all needed functions. That's true. JavaScript is also used to automate complex processes and perform HTTP requests to interact with back-end components. So like we said, you might have to reach back out, add something from a database, grab something from a database, et cetera, et cetera. That can all be done. Again, here are some frameworks. You guys might say, you're not really telling me a whole lot about how to write JavaScript. This is not designed for that. It's to explain to you the functionality of JavaScript in web applications. Sensitive data exposure. This is something that I actually harp on because one thing you'll see here is they're saying they went in here, they just viewed the page source for google.com, right? There's all this source, google.com, whatever, right? What they're talking about here is looking for valuable information from here. One thing that you will find when you start doing this is two things. One, you can see here at first the form doesn't look like anything. They look through and they see, hey, to do, remove test credentials. That is a note that a developer left in there on accident, right? This looks really silly when it's pointed out this way because that's the whole code. But the reality is this actually happens all the time. Now, one thing I get all the time from people that are like new to the industry or new to pen testing or anything like that is I get the comment like, hey, well, I've never seen that. And usually what they've done is they are looking at internet-facing, public-facing web applications. I will promise you almost every company does this. They have their web applications on the internet, public-facing, way more secure, and then internally, they have like these custom-built things they've done. They have people that stand up. They're like, hey, I built this little website so that everyone on my team can look at these articles or something. And they build these things, and they have these stood up, and they do all this crap. And it doesn't go through the same process because it's not publicly facing, and people think it's not a big concern. And guess what? That's where you find the gold. When you get in, once you get into the company, you start finding all those flaws. So you can see here is the form. You go to inspect. I didn't mean to inspect. I'm sorry. I meant page source. You can see the page source from inspect, and then you go down here and look, remove test credentials, admin, hidden in plain sight. There's the password, right? That is what they're having you do. And not only can you look for credentials, but you can look for, a lot of times there's references to different URLs or different locations that you didn't even know, different objects you might not even know existed. For instance, you might find like /images, and that's where all their images are stored for the website. And you might be like, oh, that's not a big deal, but can I access it? And can I write to it? Can I do stuff like that? So like you can start to map out the website and start to figure out, okay, maybe I have access to some of this stuff that I shouldn't, and maybe I can do some stuff I shouldn't based on different roles and things like that. HTML injection. So this is, you can see here, click to enter your username. It's a page, and then they actually were able to put in here, they put in the, right here, click to enter your username, a reference to the background image, Hack the Box Academy. And the reason they did this is because when you click this, there's no validation. There's nothing saying, hey, you can't do that, whatever. And you can click enter, and it actually will make that your background. This starts to get very dangerous when you add other users in, because if I can legitimately change the source code for a user, because this is happening on the client side, then you're starting to get in trouble, right? Okay, so what text would be displayed on the page if we use the following payload? Again, you don't even have to really do this one, but you can see it's a reference to hackthebox.com, and it says click me. So all it's going to do, if I go here, there we go. Okay, click to enter your name, and then it's saying if we use this as the actual payload, and all this is a reference to Hack the Box Academy. But it says, you notice it says click me, so it's going to say your name is click me, because it's supposed to say your name. So your name is click me. And that's an example of, you can make it do things like that, and if you're clever with it, you can make it really look odd for somebody, and they might think they're on the legit website, which they are, but it's on the client side, not on the server side, so there's not going to be a log of it or anything. There could be, but I'm just application logs and stuff, but there's not going to be alarm bells ringing, because the user is going to be the one interacting with it and thinking something's wrong. Okay, so this example here, they're going to use this to actually pull a cookie. So this is a cross-site scripting attack, and what they're doing here is, if there's no validation, they can actually put this in here, this JavaScript code, and pull the cookie. And this is actually how they can steal a session, because they can pull your cookie and then go, there's the cookie. Now I'm this user. Now let me go to the website, and guess what? I'm in. So you can go to here, and they tell you to, there we go. So now we just grab this, and you'll see it will actually display the cookie. But what you could do is, you could have it, instead of display it, you could have it actually send it out somewhere, etc. You can see it is cross-site scripting is fun. So cross-site scripting is fun. So it's a very easy, and I say easy, it's a very good social engineering attack. All right, now you have cross-site request forgery. So this is a little bit different in the sense of, you're actually going across site and requesting something, forging something, right? So you can see here, it can attack admins, gain access to their accounts. Admins usually have access to sensitive functions, right? So you can say source, in this one, example.com, exploit JavaScript. And what they're doing is they're actually having it reference a different JavaScript file, right? And if they do that and it works, you're going to my site and actually executing my JavaScript file versus the one that your site's supposed to be doing. How do you prevent these? Pretty simple. I say simple. It's simple in theory, hard to implement, and that is sanitation and validation. Make sure you're sanitizing anything that shouldn't be being input, and make sure you're validating what's being input. And if you do that, like I said, simple in theory, hard to implement, because every time you think you've got it figured out, someone figures out, oh, you can do this little trick, and now I can get around that sanitization. Okay, backend server. So we have here, they're just showing that you can have Linux or Windows servers be the backend server. Then you can have, the web server can be Apache, Nginx, IIS. Web application can be PHP, C#, Java. Database can be MySQL, MS SQL, Oracle. It can be NoSQL. It could be all kinds of things. So they're showing that there's different technologies for the backend infrastructure. You can see here's the different combinations. They have LAMP, WAMP, WINS, MAMP, and XAMPP, and that is Linux, Apache, MySQL. It's just all the components. It's the full stack, right? That's all. It's just asking, what's your architecture? You can build this out however you want, whatever works for you guys, but they're saying these are combinations that you can put together that are known to work. What operating systems is WAMP? Windows, because it starts with Windows. That's the first piece of it, right? Okay, web servers. So web server is the application, is the application that runs on the back-end server. So this is the actual thing that's running on the server. So IIS, Apache, all that stuff. It's the service running on the server that's hosting the client. All right, and you can see here is all the different successful codes. Again, I'm not going to walk you through all these. We've talked about them in the last video, but 200 means successful, 300 means redirect, 400 means client error, and 500 means something's wrong with the server itself. So you can see they're doing curl to get the headers, and they're looking at it and seeing, hey, we got the 200 error. Okay, awesome. Then they're doing curl here, and you notice they don't get the header there, but that's all right. Because you're going to get the source code, and that's because your terminal can't actually render it. It's made for a browser, so you're just going to get the plain source code. Apache is the #1. You can see it hosts 40% of the internet. Then you have Nginx, hosts roughly 30%, and then you have Microsoft IIS, which hosts 15%. And these numbers are change a lot. So when I say change a lot, Apache is usually still at the top, but Microsoft, I think, is a little bit higher than 15% at this point, but I don't know that for sure. And you can see if a web server returns an HTTP code 201, what does it stand for? You can just Google it. You have to Google it, and it will say created. That's the code. If you do 200, it's successful. 201 is created. All right. Now you got your databases. So you have your relational database, your SQL database, right? Store their data in tables, rows, columns. This is what you're used to if you're using SQL, right? You have your columns, you have your rows, and they relate to each other, right? User ID 2 here is user ID 2 over here, right? And they relate to each other. It's an easy way to pull data relationally, right? Then you have your MySQL, most commonly used database around the internet. It's an open source database, can be used completely free of charge. You have your MS SQL, Microsoft's implementation, Oracle, reliable database for big businesses, and then Postgres, another free and open source relational. Now you have your NoSQL, non-relational, right? It just stands for literally non-relational, so it's not SQL, right? So it doesn't use tables or rows. Instead, it stores data using various storage methods depending on the type of data. The big thing here is you notice it's not using data or rows. It's still using tables and posts here. There's the key, there's the value. Basically, you can see it's stored in JSON or XML. Just depends on your need. I'll say that. There's no one way's better, because a database that I build over here might not work at all for your application over here, but a database I build over here might not work for this one. They can work, they can't. You just need them to be efficient, because almost all databases can work for what you want. The question is, when you're querying something, is it taking 2 hours? Because how annoying would that be if I go onto your website and I try to use the search function and I'm sitting there waiting an hour for it to give me the results, when if you have the right database, it takes 30 seconds max, right? MongoDB, most common NoSQL database. Elasticsearch, another free and open NoSQL database. Most of you are familiar with Elasticsearch. And you notice the difference is it's good for storing huge data sets, right? That's kind of the difference there. And then Apache Cassandra. Okay, so you can see this is what it would look like. For example, within a PHP web app, once MySQL is up and running, this is how it would look, right? You're going to say, hey, connection equals new MySQLi localhost user pass, right? And then you can say, hey, SQL equals create database 1, connection query SQL, right? So right away, we're going to query and we're going to run create database 1, right? And what you do is you store these queries that you can do, and then you validate them, and that's all the functionality that the web app should have to the database. Doesn't mean it's always the case, because sometimes there's issues, but that is what the goal is, right? Is you can only do what I tell you can do on the web app to connect to the database. Now you see what type of database is Google's Firebase. It's a NoSQL database. Again, you can Google it. It's 2 seconds. Development frameworks and APIs. So the frameworks, usually used by startups, smaller companies, is powerful yet easy to develop for. Laravel, Express, used by PayPal, Django, Google, Rails, Ruby on Rails is all kinds of stuff, right? Okay, APIs. An important aspect of web apps are web APIs, HTTP requests. So basically all they're talking about here is parameters. You have to have set standards, whether that's through the frameworks, right? APIs are a set standard. If you send this type of request with this information to this endpoint, you will get results, right? And that's pretty much an API, right? Hey, we're going to open this up. This web app hosts this and does XYZ. We need to add a functionality. Cool. Open up an API, make a call, get a result. It's super easy. It's really a way for web apps to communicate sort of like without opening everything up, right? That's really the easiest way to explain it. Okay, so for example, search PHP would take an item parameter, which may be used to specify the search, pass it, through a GET request, so search item apples, right? While post goes through the body, right? So those are the parameters that you're asking for. And you could search that, right? And if you had an API, it would give you the results of the search for apples. Why is this valuable? You might say, well, I could just go to a website and type search for apples, right? But what if my web app doesn't have the functionality to actually search a database for apples? I want to actually reach out to IGA or Walmart to see if they have apples. Well, I could reach out to their API, search for apples, give you the results, and then reach out to IGA's web app and search for apples, and then reach out to County Market for search for apples, then reach out to Piggly Wiggly, search for apples, all these different grocery stores, and then give you a full list to go, here's all apples near you, right? That's an example of how I'm using other API, other functionality from other sites to do this. And that's how you can use them to communicate. The SOAP, Simple Objects Access Standard, shares data through XML. So what are we talking about here? We're talking about how are we getting data? How's it interpreted? What's it look like? This is a standard. You can use this standard. If the whatever you're interacting with uses the same standard, perfect. You guys can communicate, right? REST. This is, you've probably heard a lot of REST APIs. So REST is representational state transfer, standard shared data through URL paths. So search users one, blah, blah, JSON format. Very simple, very easy. If someone says, hey, I have a REST API, this is what they're expecting, right? They're expecting it to come in this format, and you will get this result, right? Very easy, very simple. Okay, so now use GET request index PHP ID equals 0 to search the name for the user with OK. So one thing to know about GET requests. I don't know why that just kicked on, but all right, we'll give it a sec. It's just going to spin up. Should only take a second. 39590. Okay. It might not have an actual website, but what you can do is you could just do it with a GET request on like curl or something. But with a GET request, everything sits in the URL. So I can go index.php and I can say ID equals 0. And what they're trying to do is find out who's the admin, right? So they're saying change it to ID equals 1. And all we're doing here is we're hitting the index.php site or page, and the question mark means we're going to give it a parameter. The parameter we're giving it is ID, and the ID we're looking for is 1. And there you go. You get super admin. So right there, there's no website hosted, but there's an API waiting for us to say, hey, here's the parameters we want. Give me the results. So there's super admin. All right. Common web vulnerabilities. So again, this is part of the examples of the OWASP top 10. I have no idea why they just give you random examples or where they pulled them from. I mean, I know they pulled them from OWASP, but I'm saying why they choose these ones over some of the others and why they just give random examples. I don't see the value here in what they're doing, but because this isn't an OWASP box. But hey, whatever. Good for. I can see what they're trying to go for. I guess I shouldn't say it that way, but it just seems odd to kind of just randomly sprinkle some security in there. So broken access controls are the most common vulnerability. Broken authentication refers to vulnerabilities that allow attackers to bypass authentication functions. So example, you can log in without having a valid set of credentials. You can take your set of credentials and become an admin, that type of thing. Broken access, broken authentication. Basically, long story short, I'm supposed to have X access. I have Y access. I have much higher access, right? For example, College Management System 1.2 has a simple auth bypass. Shows login without having an account, right? Malicious file upload. I don't think I need to explain that one to you, right? I take a malicious file. If I have the ability to upload something and then I can get it to run on your site, it runs usually on the back end. Now I have access to your actual server, right? Command injection. This is times where there's a lot of times where you can actually inject commands. So an example would be like SQL injection. There's times where SQL injection can turn into command injection, and I can start actually injecting commands. SQL injection. So this is exactly this, right? The query is supposed to say, hey, select everything from users where the name is like, and then you have your search function. Well, if this isn't properly sanitized, I can actually end this early because it's going to read this just like a SQL. I can do like a colon to end it and then do a next one, a next command, etc. And I can add my own commands. So that sometimes, and that's SQL commands, not command injection the same way. But you can start really getting creative with some of these if they exist. To which of the above categories does public vulnerability CVE 2014-6271 belong? And that is the shell shock vulnerability. And you can look it up, Google it, and it is just command injection. Okay, public vulnerabilities. So public CVE, as many organizations deploy web apps that are publicly used, there's common vulnerabilities and exposures. Basically, a new attack comes out, somebody records them as they get reported, and then they score them. That's really, really good. Once we identify the web app, we can search Google for exploits. We can also utilize online exploit databases like Rapid7's Exploit DB, Rapid7's database, Vulnerability Lab, all these things. And you can see that's the actual vulnerability. So you can start to gather information, look at the exploit, all that stuff. Really good information. The CVSS score is an open source industry standard for assessing severity of security vulnerabilities. So basically, you meet certain standards, you get certain scores, right? And what I mean by that is there's certain criteria that they score it on. It's not just subjective, it's objective, and it's very intentional about how they score it. So that you can see low, medium, high, severity, blah, blah. One thing I will say, though, is does not factor temporal and environment metrics. Exactly. And they know this, and they explain this very clearly, but people don't do this. And that is, you do not want to ever take CVSS scores and be like, it's a 10, we got to fix it. Because there's a lot of temporal and environmental things to consider. An example would be a 10 comes out today, right? That's the highest score it can get. A 10 comes out today. You're going, oh crap, a 10, I got to fix it. Okay, but then look at your environment. 10 comes out, it's internal, it's not exposed to the internet, okay? Already is going to drop it down a little bit. Okay, next, you have it actually segregated on a separate network because it's a dev environment or something, right? Okay, drop it down even lower because now it's not even risking exposing the whole environment yet. Okay, next you look at temporal environment or variables, like it's never been executed before. They've never seen it in the wild. It's just a proof of concept that somebody released. Am I really going to say that those three things makes this still needs to be drop everything and fix this right now? No, that means nobody's exploiting this. It's behind 2 firewalls and it's on a segregated network. No, this is like a 3 or a 4, right? So add those environment variables and consider how you score yourself so you're not just wasting everybody's time and absolutely burning out everybody by saying everything's a 10, right? So now, what CVSS version 2.0 score is public vulnerability CVE 2017-0144. And that one, you just go right here, and literally, you can I Googled the exact thing, right? And you get 9.3, put it in here, 9.3. There you go. Pretty easy, pretty standard. So next steps. They're telling you what to do. Set up a VM with a web server, create an HTML page, design it with CSS, add some simple functions with JavaScript, program a simple web app, connect your web app to a database, experiment with APIs, test it, and then adjust. One thing I will say is this is actually a good step-by-step guide, and everyone should be doing this on their home lab because of this last part. If you're interested in security, this is the best way to test your own. You can even stand up a website like Mutiliday, like Juice Shop, like any of these things, and it's a known vulnerable website, and stand it up, but you still have to learn the back-end technology, and it still helps a lot. So hopefully this helps you guys. Hopefully you guys learned something, and hopefully you guys have a great day. Thank you.